Hi students, how are you? So I hope that you are all preparing well for your JEE Mains 2023 examinations. So last few days onwards, I'm explaining all the limits and continuity and differentiability, derivatives and definite integration and indefinite integration, all those things I am explaining. Now a very important chapter, that is differential equations. So in your JEE Mains examinations, almost you will get one question from this chapter, and even though some direct questions were not asked from this chapter, but this chapter is very useful for solving the problems from other chapters. Okay now, right? So let us see this chapter. So very easy chapter. This is differential equations. So far we have learned about linear equations, we know, trigonometric equations we know, and quadratic equations we know, cubic equations we know. Okay now, what is this differential equations? The name suggests equations means is equal to symbol should be there. Okay, is equal to 0, is equal to 5, is equal to something, is equal to symbol should be there. What is differential? Differential means what? Derivatives. Differential means what? Derivatives. So this is the chapter regarding in and derived derivatives. What is it? For example, if it is a trigonometric equation, what is the definition of trigonometric equation? An equation involving trigonometric functions is called trigonometric equations, we will say. It is also just like the definition is also the same. Differential equation means an equation involving derivatives, dy by dx, dy by dx, dy by dx. This is dou y by dou x, this is dou y by dou y, dou square y by dou y, and this is called partial differentiation. Whatever may be that, we call it as a differential equation. Now see the actual definition of differential equation. Let us see what is happened. So definition of differential equation is an equation that involves, what should the equation should involve? What is the first one? Independent, dependent variables, independent and dependent variables, and the derivatives of the dependent variables with respect to independent variables. First of all, what is this independent variable and what is dependent variables? That you should know. So it is a very basic concept. Let us take one equation, y is equal to x square plus 2x. Okay. So this here you are getting two variables, y is and x. Now which we call it as a independent variable and which we call it as a dependent variable. So here x is called independent variable. Independent variable. Y is called dependent variable. Generally always x will be the independent variable. What is meant by independent variables? Here x values you can take as you like. You can take 0, you can take 1, you can take -1, you are independent of selecting the values for the variable x. That's why x is called independent variable. But what about y? It is dependent variable. That means if for example x is equal to, if you take 0, then y value is 0. If you take x is equal to 1, y value is 3. If you take x is equal to 2, 2 square 4, 2 2s are 4, 4 plus 4, 8, y value is 8. That means what? Y value, the value of y depends upon the value of x. That's why y is called dependent variable, x is called independent variable. Understand? In general, you may ask one doubt, sir. For example, if x is equal to 3y square plus 2y is there, then which is independent, which is dependent variables? Yes, this is here independent, here it is dependent. It is independent variable, in here y x is called dependent variable. Okay now, but in our course of throughout our whatever we study in our mathematical thing, whatever may be that, so x is always independent variable, y generally we will take it as a dependent variable. Okay now you understand this. So it should contains, the equation should contains independent variables. That means you should contains x values, independent x values, dependent y values, The equation should contain x values and y values, and the derivative of dependent variable, see here, the dependent variable with respect to, see here, dy by dx. So here dy by dx. What is y? What is x? Y is independent variable. Sorry, y is dependent variable, x is independent variable. See here, the derivative of dependent variable with respect to independent variable. The derivative of dependent variable with respect to independent variable, dy by dx. It should contain dy by dx. Such type of equations are called differential equations. That means simply we can say that a polynomial, where is other definition is also there, a polynomial involving derivatives. A polynomial involving derivatives is called a differential equation. That means what? D square y by dx square plus 3 into dy by dx plus 5 is equal to 0. Yes, it is a differential equation. Understand this? D square y by dx square plus 3 into dy by dx plus 5 is equal to 0. It is a differential equation. Why? Because in place of dy by dx, let us take x. So this will become x square plus 3 times x plus 5. Just like it is a polynomial form. Okay. So that is also another definition of that differential equation. Now let me explain what are the equations which are not differential equation. So if you know that also, then the definition will be very clear. Now I am going to write some differential equations which are not I am going to explain write some equations which are not differential equations. Okay. See here I am writing some differential equations, not some equations. Let us check whether they are differential equations or not. So he is saying in the definition, he is saying an equation involving dependent variables, independent variables, the derivatives of dependent variables with respect to independent variable, then they are saying that this is they are called differential equation. But see here, these are they are called differential equations? No, these equations are not called differential equations. Why? Because they cannot be expressed as a polynomial equations in dy by dx. See here, sine of dy by dx plus cos of dy by dx plus 3 is equal to 0. Yes, it is not a differential equation. Why? Because it is not a polynomial in dy by dx. Like that, e power dy by dx plus 3 times dy by dx, it is also not a polynomial equation in dy by dx. That's why it is also not a differential equation. So this is also 1 by dy by dx plus here you are seeing that x value is there, y value is there, independent variable, dependent variables, also derivatives are also there. So this is also not called, but it is not a polynomial equation. That means you cannot express it in a polynomial equation. Why? Because e power dy by dx. So it is not a polynomial in dy by dx. So therefore this is also not a polynomial differential equation. Now but see that sine inverse of dy by dx, this can be written as dy by dx is equal to sine phi. Yes, it is a polynomial. So that is a sine phi is a constant. So it is a polynomial equation in the variable in the dy by dx form. That's why it is a differential equation. So let us see that clearly what is a differential equation and what is not differential equation. Here also there are two types of differential equations are there. Let us see what are they. Welcome back. So differential equations are of two types. One is ordinary differential equations, another one is partial differential equation. In the ordinary differential equations, you will observe the derivative of dependent variables with respect to one independent variable, that is dy by dx, d square y by dx square, dy by dx, like that only you will see. Such type of equations are called ordinary differential equations. Now what about partial differential equation? Means here the derivative of y with respect to x partially. Okay, na? Right. So here d square y by, so this is called dou square y by dou y into dou x. That means the derivative of the partial derivative of y with respect to x, then with respect to y. That means it what? So we are differentiating the dependent variables with respect to both dependent more than one independent variables. Such a type of equations are called partial differential equations. But our discussion is with only ordinary differential equations only. So for our time being, we are not discussing about this partial differential equations. Okay. So let us concentrate more on this ordinary differential equations. Now, after learning this, what is meant by ordinary differential equations and partial differential equations, now the very important topic is order and degree of partial differential equation. Sorry, order and degree of the ordinary differential equation. So here onwards, differential equation means what? Ordinary differential equation only. What is the order and degree? So in our polynomial equation, we know what is the degree of the polynomial equation. That means what? Highest power of the variable is called the degree. But here, what is meant by order and degree of the differential equation? Okay, let us see that. Welcome to this topic, that is order and degree of the differential equation. So let us define the what is the order and degree. So in order means in the lower classes when you are reading differential differentials, we know that what is the first order derivative, second order derivative, third order derivative, we know that. So that means for given a function y is equal to anything, if you are, for example, if y is equal to some 2x square plus 3x is there. First, if you find out dy by dx, this is called first order derivative. Next, if you find out d square y by dx square, this is called second order derivative. So here d cube y by dx cube, so something whatever may be that, this is called third order derivative. So the order, the word order is already familiar to you in the first year of your 11th class. Okay. Now the definition see here, the order of the highest order derivative, the order of the highest order derivative of the dependent variable with respect to independent variable. Dependent variable with respect to independent variable. That means always y should be the top, x should be the bottom. Dependent variable with respect to independent. Dependent means y. Independent means x. That means dy by dx. If it is dy by dx is there, then only you have to mention the order, not dx by dy. Understand here, dy by dx only should be there. Now, what about degree? The degree of the differential, this is a very important thing. So, order we can easily identify. Order, for example, this is d square y by dx square, order 2. For example, if any equation is there, d cube y by dx cube, d cube y by dx cube into d square y by dx square, sorry, d cube by dx cube plus 3 into dy by dx is equal to 0. So this is a highest order, what is what? D cube y by dx cube. Therefore, the order is 3. Very clearly you can say, so for every differential equation, order will be there. Understand? So there won't be any confusion and anything will be there in the order. You can say easily order. If it is d cube y by dx cube, the order is 3. If it is d power 4 y by dx power 4, order 4. But very you have to more concentrate on degree. The degree of the differential equation when it is a polynomial equation. Very important. Very important. The equation should be a polynomial equation in derivatives. Understand? That means in a dy by dx, the polynomial equation. For example, you see here, is it x plus 1 by x is a polynomial? No. Why? Because here 1 by x, what is the power of x? Minus 1. Like that, if any derivative is there, for example, dy by dx whole power 3 by 2. is the highest power of positive integral index. Whatever may be the derivative, the power should be positive integral index. Positive integral index means what? Either it should be 1, 2, 3, 4, 5. Positive integral integer. That means simply it should be a natural number. So degree is always a natural number, either 1, 2, 3, 4, 5. So given a differential equation, order is always exist. Order is always exist. Degree may exist, may not exist. That depends upon the equation. Okay. So for example, if it is there, for example, this is whole power 3 by 2 is there. D cube y by dx square whole power 3 by 2. So it is not a differential, even though it is a differential equation, but it cannot be, if it is possible to write in the polynomial equation, then you have to decide. Okay. So you have to express this in a polynomial equation. That means you have to remove this 3 by 2, 1 by 2, the powers is there, no 3 by 2, 1 by 2, root 2, all those things should be removed. Then only whatever may be the highest order derivative is there, no? Highest order derivative power is called the degree. Okay. Now, for example, if you see that, is this the, first of all, is it a differential equation? Let us write it in the differential equation form, polynomial form. Multiply with the dy by dx, let us see what happens. So, if you multiply with, this is a dy by dx whole square plus y into dy by dx is equal to 1. So, this is in the form of a polynomial equation in dy by dx. Therefore, its order is first order derivative is only there, dy by dx, and the highest power. For this, what is the highest power? 2. For here also dy by dx is there, but its power is 1, but highest power is what? 2. That's why degree is 2. Okay, now what has to make you understand very clearly, now I am writing some, this side some differential equations, here order and here degree I am going to write down. So let us find what is order and what is the degree of the differential equations. Okay, now, so let us start. Let us see that. Welcome back. So here I have given 1, 2, 3, 4, 5. 5 differential equations I have given, but let us see the derivative, order and degree of these differential equations. Okay, let us see that. See the first differential equation, that is d square y by dx square is equal to 1 plus dy by dx whole to the power of 4 whole power 5 by 3 is there. First of all, is it a differential equation? Yes, it is a differential equation, but it is not in the, so immediately you can say the order is 2, d square y by dx square, here dy by dx is there, order is 2, I am writing order of this differential equation is 2, O means order. What about degree? So when I am saying degree, what I told, when we have to write the degree, the equation should be in the polynomial form. Polynomial means what? This type of power 5 by 3 should not be there. Power 5 by 3, 1 by 2, minus 1, minus 2, root 2, those terms should not be there. So you have to avoid this 5 by 3. Then what you have to do? How will that by 3 will go? If it is by 3 is not there, then it is very okay. Then how it will go by 3? So if you cubing on both sides, so this 3 will get cancel. So this is a 1 plus dy by dx whole power 4 whole to the power of 5. That means a plus b whole to the power of 5. If it is a plus b whole to the power of 5, you can expand it just like a binomial theorem. So here what is the order of this differential equation 2? What is the highest power? 3. So highest order, what is the power? 3. Therefore, degree is equal to 3. Understand? Right. Now coming to second one. Here clearly order is equal to 2. Why? Because here d square y by dx square, here dy by dx is there. So order is 2. But what about degree? So here if you observe here, this is ln of dy by dx. ln of dy by dx means what? Can we express it in a polynomial form? So you cannot express. This is ln of sine of cos of dy by dx, tan of dy by dx, e to the power of, like that. If it is there, then those are not differential equations. Okay, now that's why we cannot write in the polynomial form, even though it is order 2, degree is not defined. Understand? Nice. Coming to third problem. D to the power of y by dx to the power of 4 whole cube plus 3 times d square y by dx square whole power 6 plus sin x is equal to 2 cos x. Okay now, right. See here, order is 4. Order is, that is equal to, order of this differential equation is 4. What is the power of this highest order derivative? That is d power 4 by dx to the power of 4. What is what? This is 3. Therefore, the degree is equal to 3. So, you should not take 6 as a degree. So, in polynomials, we will take if it is a x cube plus 3x to the power 6 plus sin x cos x like that is there, then we can take x power 6. 6 is the degree. But here you should not take whatever may be the highest ordered derivative is there, for that power you have to take. That is a degree is equal to 3. As it is a polynomial equation in dy by dx, right. Coming to here, d cube y by dx cube whole power 2 by 3 minus 4 minus 3 times d square y by dx square plus 5 dy by dx is equal to 0. So, here order is equal to 3. Order is equal to 3. Now, what about degree? Is it degree exist? Let us see here whole power 2 by 3 is there. Now, can we call it as so degree is not there? Yes, degree is there. So, then what I will do now? So, I will make this minus 4 minus 3 5 divided no to right hand side. Then if it is take to right hand side, what happens? This will be plus and plus, this will be there, plus. Whole power 2 by 3, no? Whole power 2 by 3. How to remove this by 3? By 3, how to remove? If you cubing on both sides, that means if you cubing on both sides, definitely 3 will be get cancelled. So, this side, if you say this side a plus b plus c whole cube, a plus b plus c whole cube you will get. So, try to understand here. One more thing very interesting here, a plus b plus c whole cube will be there. Whatever may be that, something you will get here 3 into d square y by dx square whole cube you will get something or not. Otherwise like this. Be careful here. So, this is d cube y by dx cube whole square. Here also you are getting d square y by dx square whole cube like that you will get. Which is the highest power here? 3 not 2 now? 3 only. So, for that what is the degree? 2. That is why degree is equal to 2. Understand? Now, coming to fifth one, see here d to the power of 4 by dx to the power of 4 minus sin of d cube y by dx cube. Already I told, if it is this form sin of, cos of, ln of, log of, if it is there, it is not a differential equation, but order will be there. Order is equal to 4, degree is not defined. Order is 4, degree is not defined. Okay now? So, such things are there. So, in the second and the fifth are their degrees. For, if you observe that for all the differential equations, order is exist. The only thing does not exist is degree. Okay now? So, I hope that you understand this concept. So, let us move to next concept. Welcome back to this concept, formation of differential equations. How a differential equation will form? Okay, I will explain you using a small example. Okay, let us take one equation of parabola y square is equal to 4x. Yes, it is a parabola lying in the first and fourth quadrant whose vertex is 0, 0. How a differential equation is formed? Now I am going to explain. Now, differentiate with respect to x on both sides, y square derivative 2y, y derivative dy by dx, that is equal to 4x derivative 4. So, this is equal to y into dy by dx is equal to 2. This is the differential equation. This is called differential equation. Y into dy by dx is equal to 2. That is called a differential equation. That means, given an equation, if you differentiate with respect to x, you will get a differential equation. Y. Now, what is the, already I told you, if any equation is there, there must be a solution for that. Okay now, for example, if I say that 2x plus 3 is equal to 0, then what is the solution of this? Minus 3 by 2. How can you say that it is a solution? That means in place of x, if you substitute minus 3 by 2, what happens? That equation will be satisfied. That means you will get 0 is equal to 0. That's why x is equal to minus 3 by 2 is called the solution of that equation. Now, for this differential equation, how to find out the solution? So, in place of dy by dx, what how to substitute? In place of dy by dx, if you substitute 2 by y, then y will get cancelled, 2 is equal to 2 we will get. That means 2 by y is one of the solution. Then how to get the remaining solution? Let us see that. For that, what I am going to do is, so let us take this dy dx to that side, y into dy is equal to 2 dx. Okay, na? Right. Integrating on both sides. This is a y square by 2, 2 into for 1 x plus c, where c is called constant of integration. So, y square is equal to 4x plus k, where c is equal to, where k is equal to 2c. Put it like that. So, here if you see here, y square is equal to 4x plus k is called general solution of the differential equation y into dy by dx is equal to 2. If you k is equal to 0, what happens? Then y square is equal to 4x. That means you are already we got. This is called particular solution. One of the general solution, particular solution. Why? Because here, if you take k is equal to 1, 2, 3, 4, root 2, root 5, root 6, you will get infinite number of solutions. Sir, how can you say that this y square is equal to 4x plus k is a general solution of this differential equation? As usual, here x value is equal to how much? Minus 3 by 2. If you substitute x is equal to minus 3 by 2, you will get the answer. That equation will be satisfied. Now, what I am going to do is take this y square is equal to 4x plus k. Understand? I am saying that is a general solution of the differential equation. How can you say that? Let us differentiate with respect to x. This is 2y into dy by dx is equal to 4x 4. So, this is if dy by dx is equal to, so this is equal to 2 by y. Understand this? So, in place of dy by dx, substitute 2 by y, what happens? 2 by y will get cancelled, 2 is equal to 2. Therefore, this equation satisfies the given differential equation. That's why this is called general solution. In place of k, any real number, k you take 5, you take 10, you can take 12. Anyhow, if you are differentiating here, you will get 0 there. 0 there, nothing that. That's why, so this is called general solution. In particular, if k is equal to 0, y square is equal to 4x, you are getting the original equation. That's why this is called particular solution. So, from this we can say that every differential equation will have infinite number of solutions. Okay, na? Right. Then how to find out for remaining equations, how to find out the given a differential equation, if it is a differential equation is given, how to find out the solution. There are various methods are there that we will see in the next class. Until then, I hope that you are all enjoyed today's class with some more problems. I will stand before you. Until then, all the best.